This is Mrs. Zappia with Lesson 4 in Grade 8, Module 4, Solving a Linear Equation. Student outcomes for this lesson. Students extend the use of properties of equality to solve linear equations having rational coefficients. This lesson starts on page 22 in your book. Pause the video and copy the essential question. What properties are used to simplify and solve equations? What does it mean to solve an equation? To solve an equation means to find all of the numbers x if they exist so that the given equation is true. In some cases, simple guesswork can lead to a solution. For example, consider the following equation. 4x plus 1 equals 13. What number x would make this equation true? Pause the video and see if you can determine the value of x. If x equals 3, the equation would be true. 4 times 3 is 12. 12 plus 1 is 13. In other cases, guessing the correct answer is not so easy. Consider the equation below. Can you guess a number for x that would make this equation true? Guessing is not always an efficient strategy for solving equations. In this example, there are a lot of terms. For this reason, we want to use what we know about the properties of equality to transform equations into equations with fewer terms. That is to say, simplify before you solve. The ultimate goal of solving any equation is to get it in the form of x, or whatever symbol is being used in the equation, equal to a constant. Can you guess a number for x that would make this equation true? No, too complicated. So here we have an equation, 4 plus 1 on the left and 7 minus 2 on the right. Is this equation true? 4 plus 1 is 5. 7 minus 2 is 5. 5 equals 5. Since the value on the left is equal to the value on the right, this equation is true. Perform each of the following operations and state whether or not the equation is still true. So we start out with the above equation, 4 plus 1 is 5, and 7 plus 2 on the right is 5. And the directions say add 3 to both sides of the equal sign. Then determine whether the equation is still true. To add 3 to both sides of the equal sign, you can write it horizontally, 5 minus 3 and 5 minus 3. On the left, 5 minus 3 is 2. On the right side of the equal sign, 5 minus 3 is 2. They are still equal. For the next problem, add 3 to the left side of the equal sign and add 2 to the right side of the equal sign. In the above problem, I used the horizontal subtraction. In the next problem, I'm going to go below and do the vertical. So when I add 3 to the left, instead of writing it as 5 minus 3, this time I'm just going to simply subtract 3. Subtract 3 from the left, and then it says to add 2 to the right. 5 minus 3 is 2. 5 plus 2 is 7. These are not equal, and the answer is no. Next, subtract 6 from both sides of the equal sign. So I'm going to subtract 6 and I'm going to subtract 6 from both sides of the equal sign. 5 take away 6 is negative 1. 5 take away 6 is negative 1. These values are equal, and the answer is yes. Subtract 3 from one side of the equal sign and subtract 3 from the other side. Subtract 3, subtract 3. 5 take away 3 is 2. 5 take away 3 is 2. These values are equal, and the answer is yes. Next, multiply both sides of the equal sign by 10. We show multiplication with parentheses. Notice that you do not need a times sign. On the left, 5 times 10 is 50. On the right, 5 times 10 is 50. These values are equal. Multiply the left side of the equation by 10 and the right side of the equation by 4. Show multiplication using parentheses. The left side by 10, the right side by 4. Do you expect that they will remain equal? 5 times 10 is 50 on the left. 5 times 4 is 20. The values are not equal. Continuing, divide both sides of the equation by 2. We show division with a fraction bar. Divide by 2, divide by 2. On the left side of the equal sign, 5 divided by 2 is 2.5, or 2.5. On the right side, 5 divided by 2 is 2.5, or 2.5. The values are equal. Finally, divide the left side of the equation by 2 and the right side of the equation by 5. To show division, we use a fraction bar. On the left, we divide by 2. On the right, we divide by 5. 5 divided by 2 is 2.5. 5 divided by 5 is 1. These are not equal. The answer is no. After we've done this activity, what did you notice? And describe any patterns that you see. So pause the video and take a look at when we did the operations with the same number on the left and the right, and then when we used a different number on the left and the right. Take a minute and look back at what we just did. What I noticed is when the equation is true to begin with, such as 5 equals 5, and you perform the same operation with the same number, such as plus 2 plus 2, or divide by 2, divide by 2, or multiply by 10, multiply by 10. When you perform the same operation with the same number on the left and right, the equation remains true. Turn to the summary page and we'll record these patterns. I believe this is on page 29. In the summary section, let's write down what we have learned so far. We're going to go over the properties of equality, and we'll show them below. These are used to transform equations into simpler forms. If A, B, and C are rational numbers, and remember, rational numbers are whole numbers, fractions, decimals. If A is equal to B, then when you add the same number to both sides of the equation, it remains equal. So A plus C is equal to B plus C. This is the addition property of equality. When you start out with a statement that is true and equal, and you add the same number to the left and the right, it remains equal. In other words, if you perform the same operation with the same number, the equation remains true. Also, if A equals B, and then A minus C equals B minus C, this is called the subtraction property of equality. When you start out with a statement that is true and equal, and you subtract the same number from the left and the right, it remains equal. Next, if A equals B, then A times C equals B times C. This is the multiplication property of equality. If you multiply both sides of the equation by the same number, it remains equal. There's one more property of equality that we're going to go over, and this is the division property of equality. If you start out with two terms that are equal, and you divide both sides of the equation by the same number, where C is not equal to 0, because remember, you cannot divide by 0, then the equation remains true. This is called the division property of equality. Why are these properties important? To solve an equation, we transform the equation until you get it into the form x equal to a constant. X equals 5, for example. Let's go back to example 1 on page 25. Example 1. Solve the linear equation 2x minus 3 is equal to 4x. List the properties that you use. First, copy the equation on the right side of the page. Remember that our goal is to get the variable alone on one side of the equation. Right now, we have two terms that have the variable. So you're looking at this equation and you think, well, should I subtract 2x from both sides of the equation, or should I add 3 to both sides of the equation? Remember that the goal for solving the equation is to get x alone, and really you want to solve it most efficiently. Either of those ways will work, but one of them is more efficient than the other. Let's go ahead and write one of them down, and then we'll just look at the other way to solve the problem. So I want to move the 2x to the other side of the equation and get the variables on the right. So I am going to subtract 2x from both sides of the equation. Remember to do the same operation with the same term on both sides of the equal sign. The property that we're using here is the subtraction property of equality, because we are subtracting the same term from the left and the right. It is the subtraction property of equality. We simplify that. 2x minus 2x is equal to 0x. And that gives us, on the left, negative 3. On the right, 4x minus 2x is 2x. 2x means 2 times x. We want to undo that multiplication with division. With division, remember to use a fraction bar. Divide both sides of the equation by the same number, by the coefficient. The coefficient is 2. So we divide by 2 and divide by 2. This is the division property of equality. A number divided by itself equals 1. Remember, when you've got a coefficient, your goal is to get that coefficient to be 1. And that's why you divide by the coefficient, because a number divided by itself equals 1, and 1 times the variable is the variable. That gives us x on the left. And then for negative 3 divided by 2, you can leave that as an improper fraction, Or you could also write it as a mixed number, -1.5. I'm going to leave it as an improper fraction. It will make checking the solution easier. Next, let's check our solution and make sure it's correct. This is our solution, x in the form of a rational number. Next, check. To check your solution, you copy the original equation, 2x minus 3 equals 4x. Then you're going to replace each x with the value of the solution. So that gives us 2 times the quantity, -3/2, minus 3. On the right side of the equation, it will be 4 times the quantity, -3/2. Use your calculator and find the value on the left side. 2 times the quantity, -3 ABC2, close your parentheses, minus 3, and press equal. This equals -6. Then, on the right side, 4 times the quantity, -3 ABC2 equals. This value is -x. Since these are equal, you have proven that your solution is correct. You've checked your solution and it is correct. Now I want to point out to you, when some students check their work, they would expect to get the solution again. When you check your work, you do not get the solution. Rather, you get two terms that are equal to each other. If they are equal to each other, you know your solution is correct. Let's continue with example 2. Solve the linear equation. 3/5 of a number minus 21 is equal to 15, and list the properties that you use. In this problem, we have the value of x on the left as well as a constant, and then a constant on the right. So the most efficient way to solve this will be to take care of the -21 and move it to the right side. So you do the opposite operation. It says to subtract 21, so we will add 21. We add the same number on both sides of the equal sign. When you add, draw a bar under the entire equation. The -21 and the +21, or the minus and the plus, that equals 0. So 3/5 x take away 0 is 3/5 x. So we are simplifying the equation. It's still equal, and 15 plus 21 is 36. Next, remember our goal is to get a coefficient of 1. To get a coefficient of 1, you will multiply by the reciprocal of the coefficient. When the coefficient is a fraction, we multiply by the reciprocal, and we'll do that on both sides of the equation. A number times its reciprocal is equal to 1, and 1 times x is x. And 36 times 5/3. Well, that would look like this, 36 over 1 times 5 over 3. These have a common factor of 3. 3 goes into 3 once, 3 goes into 36 12 times. Simplify, 12 times 5 is 60. 1 times 1 is 1. And so the value of x that makes this equation true is 60. The properties that we used to solve this equation. This is the addition property of equality. When you add the same number to both sides of the equation, it remains true. Then, this is the multiplication property of equality. When you multiply both sides of the equation by the same number, the equation remains true. Next, let's check our solution to make sure it is correct. In order to check your solution, first copy the original equation. 3/5 x minus 21 equals 15. Next, substitute the value of x with the solution that you found. That gives us 3/5 times 60 minus 21. And we are going to determine if it does equal 15. Use your calculator and find the value of the left side of the equation. That value is 15. And the value on the right side is also 15. Since these values are equal, that proves that your solution of 60 is correct. Example 3. What are other properties that make solving an equation more efficient? We can use the distributive property to expand and to simplify expressions. We can use the commutative and associative properties to rearrange and group terms within expressions. Below is an example of when this would be a good strategy. Solve the linear equation and explain your work. First, take a minute and copy the equation on the right side of your paper. The purpose of this problem is to use the properties to simplify before you solve. Is there anything we can do to the linear expression on the left side to transform it into an expression with fewer terms? Notice that we have like terms, 1/5 x and x. We can use the commutative property to rearrange and put the like terms next to each other. Bring down 1/5 x, then add x, then add 13. Remember that x has an invisible coefficient of 1. 1/5 x plus 1x is equal to either 1 1/5 x or 6/5 x. Bring down the plus 13. So we used the commutative property to rearrange that problem, and we simplified our terms. Is there anything we can do to the linear expression on the right side to transform it into an expression with fewer terms? We do have like terms, the constants. We can add those together by rearranging. So we're working on the right side of the equation right now, and I'm going to rearrange these terms. You want to be especially careful when there are subtractions to make sure that you move the entire term with the subtraction sign. So we're moving the plus 22 to the front and the minus 9x to the back. Again, be careful to keep the subtraction sign with that term. And 1 plus 22 is 23. 23 minus 9x. Now these terms cannot be combined because they are unlike terms. We still know that these expressions are equal to each other. Each side of the equation is in simplest form. So now we are ready to solve our equation. Now we have to look, do we want to move 13 to the right side of the equation? Hang on a second here. Let's do that a little bit smaller. Moving 13 to the right side is one of our choices. We could also add 23, or rather subtract 23, from both sides of the equation. We could add 9x to both sides of the equation, or we could subtract 6/5 x from both sides of the equation. So really there are four things to choose from. And you think, well, what's going to be the most efficient? Well, remember that our goal is to get our variables on one side of the equation by themselves. So I'm going to choose to work with the variables first. So now I have to decide, do I want to subtract 5x from both sides of the equation, or do I want to add 9x to both sides of the equation? Well, I don't know about you, but I prefer addition. So I am going to add 9x to both sides of the equation. This is the addition property of equality. I know that on the right side of the equation, this is going to equal 0. And so on the right side of the equation, I simply have 23. On the right side of the equation, I have 6/5 x plus 9x. Remember that 6/5 x is equal to 1 1/5 x. So 1 1/5 x plus 9x is equal to 10 1/5 x plus 13. Next, I want to get my constants on the right side of the equation. So I am going to undo adding 13 by subtracting 13. This is the subtraction property of equality. You do the same operation with the same number on both sides of the equation. On the left side, the plus 13 and the minus 13 equals 0, and 0 plus 10 1/5 x is 10 1/5 x. On the right side, 23 minus 13 is 10. Next, I've got 10 1/5 x equals 10. This means to multiply. The opposite of multiplying is dividing. In order to divide with a mixed number, I will need to change 10 1/5 to an improper fraction. 5 times 10 is 50. 50 plus 1 is 51. 51 over 5. Now I'm ready to divide by 51/5. When you divide fractions, you multiply by the reciprocal. Show multiplication with a parentheses. Multiply by the reciprocal, 5 over 51. 5 over 51. A number times its reciprocal equals 1. 1 times x equals x. So now it is in the form of a solution, and we just need to multiply to find our final answer. Ten times 5 over 51 is 50 over 51. This is in simplest form, and the answer, called the solution, is 50 over 51. To check our solution for this problem, we'll go back to the original equation and write it down. That gives us 1/5 x plus 13 plus x is equal to 1 minus 9x plus 22. Now to check our solution, we'll replace each value of x with 50 over 51. That gives us 1/5 times 50 over 51 plus 13 plus 50 over 51 is equal to 1 minus 9 times 50 over 51 plus 22. Now using your calculator and your ABC key, calculate 1/5 parentheses 50 ABC 51, close your parentheses, plus 13, plus 50 ABC 51, and press equal. This gives you a value of 723 over 51. In simplest form is 14 and 3/17. Press clear and calculate the right side of the equation. So we have 1 minus 9 parentheses 50 ABC 51, close your parentheses, plus 22, and press equal. The value is 14 and 3/17. Since the values are equal, you have proven that the value of x that makes this equation a true statement is 50 over 51. When you get two values are equal, you have proven that your solution is correct. You have checked it. We're going to skip ahead now to the summary. We've already filled in quite a bit of it with our properties. So in this lesson, we have learned that we know the properties of equality. When used to transform equations, make equations with fewer terms that are simpler to solve. When solving an equation, we want the answer to be in the form of the symbol x equal to a constant.